Metallurgy is sort of the foundation of material science. It's where most material science departments and the field began. So it's one of the fundamental elements or parts of what material science do, particularly from a teaching perspective. The theory and the knowledge base of material science was really developed through metallurgy. So a lot of the underlying science and techniques and understanding of materials, regardless of what they are, came directly from the study of metals.
Metals are very important for day-to-day activities. They are an incredibly useful engineering material. Everything from making mundane soda cans to the fuselage in your airplane. The MetLab is a shared research facility, which means that anyone within the institute can use it and get trained on the equipment and enable their research. We have plenty of users from all over MIT who use our equipment for looking at polymers, composites, ceramics, semiconductor materials, so on and so forth.
Really important to us is the fact that we build a lot of multi-material structures. The MetLab's facilities, including their video extensometer and digital image correlation system, allow us to test our soft materials, but also to localize the deformation. I'm really excited to be here at the Department of Material Science because I get great students and excellent resources like the MetLab to solve these problems.
It's very important for us to be able to prepare our samples well, and for our samples to have, for example, deformation-free surfaces. You can have the most advanced characterization technique, but if you can't prepare your samples properly, if you don't have the right metallographic procedures and equipments, your experiments will not be successful. It's critical to have MetLab that provides us opportunities to prepare our samples in a deformation-free manner.
The mission of the MetLab is to support research in the department. It's mainly a metallurgical facility, so heat treating, specimen preparation, polishing, etching, mechanical testing. But because those techniques overlap with the broader field of material science, the MetLab gets used for research in other departments across our department. So it's really a broadly used facility.
Several classes in our department leverage the MetLab for teaching. Professor Tassan's course in mechanical properties of materials uses MetLab facilities to teach undergraduates the fundamentals of mechanics.
One of my aims was to take freshmen, MIT freshmen, and bring them into this lab to get hands-on experience using metals, learning by completing simple forging projects, begin to ask questions about, well, what is this material? What is its chemistry? Why do you have to heat it? Why does it get softer when you heat it up? What happens when you quench steel and it gets really hard? All of these things are natural questions that people would have when they take up something like blacksmithing.
The MetLab has been a really excellent resource. As an undergraduate, when I graduate, I know that I will have more skills in hands-on material science. That's super valuable because I'm able to learn those things now as a sophomore, and then when I get to grad school or head into industry, I'll have access to that knowledge and those resources. It'll save me time, and it'll also make sure that my research and my learning continues in the future.
The MetLab gets used across the curriculum: metals preparation, polymers preparation, cement, concrete, electronics. I think underneath it all, the MetLab is there to serve its users, to be there as a foundational tool for all of the people at MIT who are doing groundbreaking research, both in actual physical instruments, but also in the people in the community that run the space.
It's been a real privilege to teach a lot of these undergraduate, graduate students, postdocs, and help prepare them for a career in metallurgy and material science. They're going to remember what they learned here. and carry it forward. Although metallurgy is an old field, it's not about preserving the ashes, it's about keeping the flame burning. I've been really happy to see it grow and see it continue to be used by the Institute in our department. With where material science and engineering is going, I don't see it stopping anytime soon.